welcome. Thank you all very much for coming. We appreciate everyone coming to our session this afternoon. My name is Tyler Redslob. I'm the Vertical Market Manager for Process Industries at Phoenix Contact. Our session this afternoon is going to be on single pair Ethernet and APL, the future of Ethernet networking in industrial communications. You will all be pleased to know that there will be only 1,000 slides of PowerPoint this afternoon. No, I'm just kidding. Actually, there will be no PowerPoints this afternoon. This is going to be a panel session, and we are very pleased this afternoon to have our panel up here this afternoon. Our panel consists of several people, and I will start with Guadalupe Chalice. She is Senior Marketing Specialist with Phoenix Contact. We have Tim Shope, Vice President of Digital Transformation Solutions of Endress+Hauser. We have Jason Norris, who is Group Leader of Process Automation at Phoenix Contact. And we have Cristobal Ruiz, who is Process Automation Manager at Dow Chemical. And our moderator is going to be Mr. Harry Forbes of ARC. And with that, I'm going to turn over to Mr. Forbes, who will be moderating our panel this afternoon. So thank you. Please enjoy your lunch, and thank you for coming to our session.
Okay, as analysts tend to do before we start, I do want to say a few things. I was having after session beer, amber liquid, with one of the fellows I consider to be kind of a guidepost in the automation industry. And after we had lubricated ourselves sufficiently, I said, you know, what do you think is going to be the biggest change? And we came up in our industry, and we came up with two changes that we thought were critical, and one of them was APL. We think this is going to be a revolutionary change in our industry, and it may be a little bit disruptive, it may be a little bit bumpy, but we think that it's fundamentally something that is changing in our industry that has been a chronic pain point and a difficulty since we were college graduates, which was a few decades ago. Why is that? Well, really, process field devices in the process industries have never, ever had true networking capabilities. We've had field buses, we've had field bus wars, but we've never had a process field device that can handle the Internet Protocol Suite and an IP datagram. There's a little bit of exception there, but not very much. So IT got this networking capability in the 1990s, so it's been 30 years and we haven't had it in the process field for some good reasons, some not so good reasons. So I would also say that device management as a discipline and as something that's useful for manufacturers has suffered incredibly because of this. And Ethernet-APL is certainly going to change that. I could think of, let me just think of a couple of examples. I mean, one of the pain points that we see all the time at ARC is device management, software deployments. I don't know, our panelists can speak to that, but device management tools really cover a very small segment of the installed base of field devices. So if you look at, if there are 40,000 field devices in a plant, how many of those are really managed and monitored by a field device management package? If it's 1%, that would be startling. It's a very small percentage, and it's usually only the most critical devices where they can devote the resources. Why? Because the interfaces are difficult, the knowledge needed is labor intensive and specialist, and because really the solutions don't scale, because the networks don't scale, because there's not a true network. Let me give you a use case of that. There was a particular device manager, not Endress+Hauser, but had a problem recently with a particular set of devices and said, okay, this device is likely to fail or it's corrupted, and you need to know that this model, this revision of firmware, you need to take those devices out of service. Well, how long does it take an end user who has maybe thousands of devices of a family to know which model, which revision is installed where? And it took them weeks. So whereas if you are in the IT world, if you need to know, even though it's not as critical perhaps to safety or production, if you need to know what's deployed in the IT world, your IT department probably knows exactly. So I would say those are two use cases, the ability to scale device management, the ability to understand the installed base, and third, I'll give one more use case, is the ability to enforce best practices for device configuration and management. For instance, in my ancient youth, I used to work with a refining company that had particular specifications for flow control loops. So flow control loops would be integral only, and this would be the range of integral times that they would allow for flow control loops. But how did they know that? No idea. And I'm sure if they have that policy in place, which they probably still do, they still don't know because it's impossible for them to extract that kind of information. So what we can get out of this is device management on a big scale that's scalable, understanding what our installed base is, and also consistent best practices. Those are the kind of use cases that I see. And so it's something I'm genuinely excited about. So with that, I'm gonna stop yakking and turn it over to the panel and talk a little bit about that. And I'm gonna start with Guadalupe, if that's okay, because what our Ethernet-APL is, as I understand it, really a subset of a technology, an IEEE technology called single pair Ethernet. And so another nice part of APL is that it's not entirely dependent on a technology for the process industries, but it has applications in other industries, including automation. So Guadalupe, I wonder if you could give us a little perspective on how single pair Ethernet has evolved and what kind of industries it's serving and what its applications are outside and inside our process industries.
So, hi everyone. Can you hear me okay? Okay. So I think that's a good question. I personally work in device connectivity, so not necessarily specific to process automation. And my background is in automotive connectivity. And when I started my career, I started designing Ethernet connectors, single pair Ethernet connectors for automobiles back in the 2010s. So SPE is certainly a technology that has been around for a little bit. And APL is just one of those use cases. There are already deployments in automotive, and there's a lot of standards, especially IEEE standards that address speeds, distances, power, etc. What I think is very interesting is that APL takes one of these standards and adds intrinsic safety, right? But I like to address the SPE umbrella because that is only, what APL does is takes only one standard, but there are other standards out there and other distances and speeds, etc. So from a connectivity perspective, especially for the device, SPE is a scalable technology. So it's not only going to serve your 10 megabit per second applications or your lower speeds, it can certainly grow with your devices, with the speeds of your devices. And it is what we are seeing in automotive. So when I started working in automotive, the specifications were 100 megabits per second on their unshielded twisted pair. because they wanted to do Ethernet, but they didn't want to use 4 pairs and they didn't want to use shielding because it's too heavy to install in a vehicle. And now it has evolved to multi-gig. So now there are standards out there with 10 gigabit over a single pair. Of course, these are short distances, up to 15 meters. Cars are not that long. When we come to process automation, now things are a little different. So we look at the 10 megabits per second, 1 kilometer, and that's fine. The message here is that as we continue to work on the use cases, it doesn't stop there. So it doesn't stop at 10 megabits per second. It doesn't stop at 1 kilometer. It can evolve with the applications. And now we see specifications coming out for 100 megabits up to 500 meters, for example, or the 1 gigabit per second specification going to 100 meters and so on. So it's definitely something to keep in mind and to think about it as the future of field device connectivity, not only in intrinsically safe areas, but for other applications as well.
Can I follow up that with a question that's off script, Guadalupe?
Yeah, sure.
Did you have any idea, in automotive is something that gets process automation people interested because there are so many cars built and so many interfaces. So what are the prospects for SPE penetration into automotive? I don't know anything about that, so.
So SPE in automotive has been, it has been in use since, I would think the first project started in around 2010. So it's not that every single device or sensor in automotive is using SPE, because there's CAN, and CAN is, it's been around for a while. But for those nodes that require the higher speeds, now Ethernet is used. So it's definitely there, and it's definitely being in use, especially for infotainment systems, so rear view cameras and sensors in the mirrors and things like that. So it's definitely a technology that is already in use.
Okay, thank you very much. Jason, I'm going to kind of turn to you if that's all right. What would distinguish, instead of talking single pair Ethernet, maybe talk about Ethernet-APL. What about the switch and the infrastructure is different from between an Ethernet-APL infrastructure and a conventional Ethernet infrastructure and SPE infrastructure?
Yeah, good question. Especially calling attention to conventional Ethernet switching. It's interesting to have a conversation about connectivity of APL in, just the physical layer standard brings to life new possibilities, right? But what does that actually look like? And you keep, it's Ethernet-APL. So in an Ethernet switch, you're used to seeing RJ45 connectors or a fiber optic or SFP port, usually, skinny pieces of hardware snapped on a DIN rail. But, the application space for APL, is hazardous locations. It's devices typically further away from a switch than conventional Ethernet allows you to go. And these devices are out in areas that have high electromagnetic noise interference, or, it's devices next to a motor or a drive. So there's concerns over, noise and isolation and so forth. So if you think about an APL device sitting in the field that is an Ethernet device, what does it terminate on, and what does that actually look like? So the switching infrastructure becomes a little more complicated because you have power isolation, you have intrinsic safety for hazardous areas. That's like Guadalupe said. Ethernet-APL brings intrinsic safety to the networking space. So all of these technology blocks or functional blocks get added into the switching infrastructure and really create sort of a different feel. And you first notice it when you go to plug in a device and it's plus, minus, and shield discrete wiring and not a click of an RJ45.
Okay. Now I'll turn to Cristobal. You're an end user. You're the end user here at the panel, obviously a very major end user. So could you kind of summarize for us what, from the end user perspective, your view or vision is that the benefits you'll derive from APL devices?
The perspective that we have in terms of the usage of Ethernet-APL is aligned with initiatives such as NOAA and OPAV. It is managing obsolescence and removing roadblocks on the data flows. What that means is with the current infrastructure where devices have to talk to an intermediary, meaning the IOs, even with a gateway, the data goes concentrated through the DCS, and access to it, even by other platforms, you have to do some sort of customization if you want to use a platform, to your point of intelligent device management. And there is, efforts done between vendors, but that also comes at a cost. And ultimately, it doesn't solve the problem of the data flow. And it doesn't solve the problem of obsolescence. So utilizing Ethernet-APL from that point of view brings multiple solutions to the root problem. Everything else is just a symptom, right? You cannot talk about Ethernet-APL without addressing utilizing open standards as well. So our approach is also from a holistic perspective, because Ethernet-APL cannot be deployed either if the logic solver doesn't play well with the open standards that we're planning to utilize and for the applications that we want to utilize. The success of Ethernet-APL also lies on the EPCs that we may try to work with the integrators that we would be working with, right? So every single, let's call it, team within the delivery of a project, whether it's a brownfield or there is a greenfield, plays a critical role in ensuring the value of the investment. So it's not something that is up in the vacuum. It's not solved just with providing a switch or providing the devices. So it's really a holistic perspective that we try to give it to the implementation of this technology.
Okay. Well, let's switch to the vendor perspective, and I'd like to ask Tim a little bit about that. A lot of times in the reaction to the field bus wars and the fragmentation of field bus technologies, vendors kind of took a modular approach a lot. Okay, well, plug in an adapter for this field bus or that field bus. But I know you all had, at E&H, you had some devices exhibited, at least at the last ACMA show. Mm-hmm. So you've been working on this. Can you kind of tell us what changes you made to devices for APL, and how is it changing what you expect devices to do? And what is the impact on E&H of deploying APL devices versus the existing field bus technologies?
Well, that's a great question. And I think with my role in digital transformation for E&H, I'm not nearly as just device-centric as I am what can we do with multiple devices connected, right? So back to your use cases, if you look at asset management for years and years, we had tons of information that was orphaned in the field that could never get anywhere. We've used basically, am I talking to the remote IO? Do I have 4 to 20 channel that's good, and is my PV somewhere between X and Y? Then that was the qualification for this instrument is healthy. Let's use the value, right? So you've had numerous model-based controllers that work great for 6 months and don't work after 6 months later because you're not looking at the health and status of the instrument. You're looking at the health and status of the 4 to 20 loop. And I think when we get these devices openly communicating to a on-prem or cloud-based asset management, then you have devices that are capable of essentially phoning home, right? We've done this already in a number of different ways with our Natilian Health. We've done API ingestion into cloud-based CMMS platforms to where a instrument may have a more maintenance condition, and it literally will hit the API, and we can actually have a service tech come deploy to fix that instrument or workflow kick off inside the CMMS autonomously. So those are game changers compared to how we've traditionally looked at it.
Really, and also scalability,
Yes.
right? Because you've got a true network, so not your instrument can phone home, but if you have 10,000 of those instruments, they can all phone home.
Yes.
Okay, I'm going to switch gears now and talk about one of the other things that I didn't mention at the front of the talk, which was cable reuse. And years ago, when we first started talking about APL, and cable reuse is absolutely necessary in the process industries to get into the brownfield, which is really most of the business. But cables are old, and people don't trust them, or really it's something you don't want to touch. A lot of times for retrofits of automation systems, they won't even touch the field devices or the terminations because they're scared of disturbing the cables. It's just there's no winning in disturbing the terminations or the cables. So cable reuse is one of the things that is a mandatory for APL. And I'll go to Jason and ask, what are people expecting? How can they be reassured that their cables are in condition to actually be reused? Because they're putting a different infrastructure and a different device in now, and they kind of have to have a lot of faith. So if I don't have faith in my cables, if they're 20 or 30 years old, what do I do?
Yeah, this topic was really first and foremost through the requirements writing of the specification for APL itself, for exactly that. Borrowing from what was learned from Foundation Field Bus too. Back in the Field Bus days, before they were with Fieldcom, they would have Duke Energy talk about how they were able to reuse their entire plant cables and migrate to FF. And then others started trying that and weren't as successful as Duke because their wires weren't as good or maintained as well as Duke Energy did. So they backed away from talking about that till there was really an understanding about, well, what is a good cable in the context of the protocol. For Ethernet-APL, so we don't talk about a protocol. We don't have to worry about that. It's just physical layer. It's plus, minus, and shield twisted pair cabling, 10 megabits, half a watt of power, 200 meters. So at the very beginning, it was in the standard is a recommended cable parameter that you're supposed to use. However, the working group put together an engineering guideline that says we understand that you have existing cables and you don't want to reinvest if your cable is good enough. So the real question is what's a good enough cable? So that's still, the process of determining that is not anything that's, written down that you have to exactly follow this, but there's a lot of discussion about this. Even the 5 vendors for APL chipsets are talking about putting in extra diagnostic functionality to be able to do cable checks upon commissioning. And prior to getting to commissioning, just assessing your cable, understanding where it was sourced from, what the impedance of the cable is, and double checking your lengths. There is a clear path to being able to reuse cable so you don't have to reinvest, but it's definitely a topic because you just follow this from step 1 to end and you're good. But within the guidelines, you may have cable that's not as optimal as it should be, but it's good enough, and if you use it, it comes with the expense of, instead of 200 meters, maybe you could only go 80 meters. But there's guidelines to kind of get you in that camp.
But that kind of thing gives me a little bit of fright. But one thing that reassured me was talking with one of the chipset vendors, ADL, at Acoma, they demonstrated some diagnostic capabilities that they had built into the chipset, and I wonder if you wanted to expand on that. Cristobal, are you familiar with that?
So I would begin by saying the following. There's no point in talking about reusing the cables if I'm migrating from HART, for example. Am I going to replace 10,000 instruments? So there's really no point also talking about reusing the cable. Let's say the infrastructure is foundation field bus and the segment coupler is this size. And with that IO density, I'll have to look at what I would need to install in the field just to try to reuse a cable. And even if it was, you say you want to continue moving forward with your exercise, a 48 IO point junction box, how many cores would the multi-core cable that comes all the way back to the RIE will have? So really, the discussion of trying to reuse the cable it's something that would take place so far down the road if you haven't done an upfront assessment of what is your current install base. So that takes care of that. Now, are the diagnostics for the physical layer necessary? Absolutely. Because one of the major problems faced during the deployment of field buses was improper cable installation, improper grounding, a lot of noise. So the solution that is out there, there's only one solution out there, has the capability of providing diagnostics. So you can look at the voltage range that you're getting on every port. You're getting also a noise level on every port, and you're getting the signal jitter fluctuations as well. Hands down, it's going to be necessary. You can skip it, but one way or another, you're going to have either a portable device that you're going to have to plug into your topology and verify a proper physical cable installation, that you didn't exceed the distances, that you don't have too much of a voltage drop, et cetera, right? But I hope this makes the point clear.
Tim, I don't want to leave you out here. Do you have any, what are you hearing from your customers about APL and existing infrastructure and cabling?
So certainly there's a lot of want to be able to reuse existing cabling just for a cost and economic standpoint. But we're actually looking at that and posed it to a lot of customers. Is that a service that they would be willing to consider to go out and inspect their cable runs, inspect their cables, figure out the impedance runs, figure out what their infrastructure looks like, and you know, to Cristobal's point, you probably don't want to do this to every instrument in a facility, right? You're going to take critical instruments, you're going to take instruments that may or may not already have diagnostics that are orphaned in the field, right? That it's not going to be everything. It's going to be 20%, 30%, and then can we provide a service that would say, yes, we qualify this cable as a good run?
Okay, another thing that gives me nightmares is there's always a double-edged sword. It's revolutionary that we have the ability for field devices to have Internet Protocol Suite on them, but it's also a security risk because they've never been reachable by outside attackers before. So let's talk a little bit about what goes on to secure this new infrastructure and these new devices. I know, Jason, you've been involved in the development of the infrastructure and the specification, and I'd ask you to maybe start, but anybody else who wants to dive into that topic of how we need to secure these field infrastructures and devices.
Yeah, I can say from our perspective, and I don't know, Cristobal, you might have like an opinion or a statement at the wider level. So, you know, Harry's first question, you know, what does the infrastructure look like? You know, our focus is getting the APL device to connect into the network. So, you know, creating the intrinsic safety, the power isolation, and all the good stuff. But the switch is a participant on the network, right? It's, connects into, let's say, a layer 2 managed switch. So from our perspective, where we're making this connection to the network, our focus is on what are the good practices in developing switching infrastructure. Any of the web interfaces, having, SSH security level to get to it, authenticated user access for one, and when you get in, or role-based access, getting inside the switch, being able to control the ports, MAC-based, port security, if using SNMP, using encrypted, SNMP v3. So where the user would interface with the infrastructure, we're focused on the security mechanisms to at least try to secure the switching asset itself as best as possible. But, as you go north of it, I'm not sure, Cristobal, if you have.
Cristobal maybe has a comment. I'd be interested to know what, have you talked to what do your IT folks say about this, or your security people?
No, there's definitely cybersecurity in mind. From the switch perspective, I don't expect them to have any less security than what a regular layer 2 switch already has, right? Encrypted passwords, HTTPS, if enabled, et cetera, right? We're thinking more from the perspective of the attack surface is going to increase, right? We're going to have way more network cabinets in the field. How are we going to manage them? So we're looking into different technologies readily available, and you just need to ask yourself, how does Cisco manage an install base of 10,000 switches from a domain? Am I going to have to put in a username and a password for 10,000 switches? Am I going to have to manage 10,000 devices with a username and a password? So cybersecurity is there in mind, and it's one of the things that we're evaluating and putting into the user requirements. Every network is going to be subject to the same rules as defined in 62443 of zoning and conduits. So there's definitely some legwork that needs to be done, because again, the networks are just going to become bigger. But it doesn't deviate from any other cybersecurity principles already well known and well established.
Okay, I'm going to maybe ask Guadalupe about this. If, from the perspective of SPE versus APL, it seems like there's a difference in the installation. He said you've got shorter distances, higher speeds, but not that many devices on an automotive or application. Do you think the automotive OEMs and parts suppliers have are you aware of anything they've done in this area for security? What kind of things are they doing?
Yeah, so for automotive, it works a little bit differently because you are kind of encapsulated within a car, right? So I think the one thing they have done is go into zonal architectures and kind of segment the different areas, so like the ECU versus the infotainment systems and things like that, as far as I'm aware. Now, that is not necessarily something that might apply to process automation, but it's the way that automotive has addressed it. And they actually, so as a proven use case, they have put out standards and have come together and worked on these specific issues, aside from whatever the IEEE has done. So it will probably take for us to come together as well and work on those. And I see that with the ODVA versus Profibus coming together and also talking about those topics of security for sure.
One thing that I do want to add that perhaps I forgot mentioning is that there is recently revealed an effort between the Philcom Group, the Profibus organization, ODVA, and the OPC Foundation on harmonizing cybersecurity. I can only speak for what the Profibus organization is doing, but having certified GSD files. It's one of the things that they're doing, as well as having discussions on putting encryption on the actual protocols themselves. So it's an effort that really goes beyond just what the switch manufacturers are doing.
All right, well, any other comments on security? I don't know if this is your place, Tim, but what are you hearing from customers about that, or from your developers?
So certainly from our development standpoint, we're making sure that all of our instruments are 62443 capable and compliant. It's not a lot different. I mean, we've had Profinet, Ethernet-IP, and MCCs for, a decade now, right? It's been deployed that way. Customers are getting a lot more secure in their ability to do layers of protection to secure the infrastructure. It's just going to be a different way of thinking about an instrument in the field as opposed to a DLR and an MCC. But it's really no different, right? You're getting more and more intelligent field devices connected.
Well, we're almost out of time. If there's a question from the floor, we could probably take one or two. Yeah, please stand up and speak loudly so we capture you.
I was just wondering about the lightning protection mitigation for short burst transient surges on these cables. What's the? You could enlighten me about that.
Okay. Or are we stumped?
We're looking at
We're looking at Jason now.
Yeah, from a surge transient perspective, the cabling, the physical layer part of it, right? 2-wire plus minus and shield. There's grounding practices, of course, for terminating your shield, but then the application of arresting surges or transients is definitely applicable in APL. If you're asking about like a strategy perspective, protect the instrument, protect the switch. My experience with surge is, it's what asset you're trying to protect. You want to put an arrestor close to that asset. So I know that our surge business unit already has, it's about matching the impedance of the cable and making sure you have a pass-through capability and so forth. There's already designs for having surge protection for APL signals, the APL physical layer itself, and the port profile standard does support the use of surge protection and transient protection.
Okay.
On the Ethernet-APL engineering guidelines, there is actual section, and they refer to it as APL accessories. Let's call them accessories. And it provides you with guidance in terms of where on the segment to install it, what will be the maximum number of accessories that you can put in order to avoid exceeding the voltage drop levels, the impedance generation levels, and everything that you put on the segment essentially will introduce signal reflection. So there's a lot of guidance. I wouldn't say a lot because maybe perhaps it couldn't be improved, but there's already guidance taken into account on the APL documentation.
And that's provided by the APL organization, Cristobal?
Yes.
Okay. Well, we do have to bring this to a close because we have to keep everything on time, so it's time for us to stop. Please, I hope you will give some thank yous to our panel, expert panel. Larry, is there something on your? It's on the Ethernet-APL website, right?
Yeah, I mean, I was actually giving a talk at Endress, and a guy said, "Okay, Google, show me the engineering guidelines for Ethernet-APL," and it will pull up the PDF for you.
Yeah, it is a
Readily
free download. Yep.
Okay, well, this has been a very knowledgeable and helpful panel. I hope you've enjoyed the session, but let's show them our appreciation.